Okay, I just wanted to make a talk a little bit about some of the general effects of adding zeros and poles. We've been talking about this, kind of been dancing around this actually. We've been talking about adding a zero or a derivative term. We've been talking about adding poles, an integrator. We've been talking about it in the lab in terms of a PI or a PD controller. And so I just wanted to make some general statements about this. And you'll see them here on your screen. The general effects of adding a zero. It pulls the root locus to the left and makes the system more stable, and speeds up the settling response of the system. And here we're talking in general about let's just imagine a second order system here. We got a couple of poles here, and in this case our root locus without any kind of controller, or just a simple proportional controller, would look like this. In this case, we're assuming that we're putting the zero out here to the left of the existing system. And in that case, what's going to happen is that these branches now are going to pull over here and meet up on the real axis. One's going to go to this zero and one's going to go out to infinity. And we can drive the system by changing the gain to some points out in here and have our closed loop system out here acting quicker, and it would become more stable because the right half plane is instability. So we move away from the right half plane. We move farther along the negative real axis. So we've got a quicker system that is more stable. And so now that's just the general rule for adding a zero. So if you were looking at a system and we want to speed it up, the first thing that should come to mind is a PD controller, okay, a proportional derivative controller. That's going to speed the system up. Okay, so now let's look at the addition of poles. Now we just spent some time thinking about steady state error, and so what we're going to have with a pole is we're going to improve the steady state error, reduce the steady state error. And so it's going to pull, in general, it's going to pull the system to the right, because let's imagine again our second order system here, and look at our root locus with just a proportional control, and it looks something like this. And if we add a free integrator in here, like at our origin, what's going to happen with this is that it's going to remake our root locus. In this case, we're going to have it going like this and here. And so we've pulled our dominant poles, which are going to be the ones closest to the origin, pulled them into the right half plane if we increase our gain. So we've reduced the stability of it, and but we have been successful in reducing the steady state error. So if someone is looking for reducing the steady state error, what you should be thinking is a PI, but it comes at a price. It comes at stability. It slows the system down in most cases. Now, these are general effects. Remember, general effects. We can do more with these, but in general, the zero pulls the root locus to the left, makes the system more stable, and it speeds up the settling of the response. And adding of a pole, assuming we're adding it as a free integrator, pulls the root locus to the right, lowers the system's stability, and slows down the settling of the response. And in this case, one thing that they don't talk about here in this is the reduction of the steady state error, reducing or eliminating steady state error. So claims to fame, the PD is speeding it up, making more stable. The PI is reducing steady state error, but it comes at a price with stability.